Hey, what's up guys? Gonna do another tutorial today on planetary character stuff. Today I'm going to talk about doing multiple planets and how to switch between them. So you can see here I've got my template guy set up to do this, and I'll go through how to do this with the tutorial pawn here in a second. And you can see that it works pretty smoothly. So that you can move between the planets here, standing on the side / top of this. I guess this would be the pole right there. And then I can jump up to here and land on this one and fly over and then get on this one. So let's go ahead and dive right in. I've got some debugging stuff going for the template. So the first thing we'll do is I have it set on the template game mode, so I'll go ahead and switch that back over to the tutorial game mode. So you'll notice now that if I do this, that we go to the tutorial planet, which, while it looks identical to those three, is the one that we did in the last tutorial. And these three are template planets. So I'll go ahead and delete those out just so we have just our tutorial planet. And we'll go ahead and copy it out. So we have two planets here. And if I play, we'll go to this one. And it doesn't matter what I do, we're going to gravitate towards this one, and that's because in the template pawn, sorry, we go back to content, tutorial. In the tutorial pawn, on event begin play, we get all actors of class, and we set the first of the tutorial planets, the first one in the array, index 0 to planet, and we don't do anything else anywhere else in the game. So the first thing we need to do is set this to whatever is closer. So let's go ahead and do that. Again, we're working in event tick, not great. Disclaimer, don't use event tick. I'm going to use it here. That's that. So let's create a function and call it set planet. This is going to be in charge of figuring out what planet this variable is going to get set to. So we're going to add another variable, and we're going to call it planets, and it's going to be of type planet, tutorial planet, object reference, but we want it to be all of the planets. So let's go over here, and under this, click it and select array, so that it's an array of planet object references, tutorial planet object references. And on event begin play, let's go ahead and also set planets to this, just like that. So now we have, at the beginning, we get all of the planets that are out there. This won't handle dynamic spawning of planets, so if you want to add that, you're going to have to do this every time you spawn one. You'll have to reset the array, but since I'm placing them in the editor and I'm not placing them during gameplay, this will work just fine. And then let's jump into our set planet function here. So the first thing we need to do, well, when do we want to change the planet that we are gravitationally attracted to? And that's if we're closer to the other planet. And this is easy if they're equal-sized planets, like we have here. It gets harder if one of them is scaled, but I'm going to go ahead and show you how to do it with a scaled planet so that it's the distance from the surface and not the distance from the origin, because what can happen is if you are, say, right here, you would think, oh, I'm closer to this planet, but if you just do the distance between this actor and this actor, you're a lot farther from that point than you are from that point. So you'll go to this one, even though you'd think you'd go to that one. So we'll include that and fix that in the tutorial here. So what we want to do first is get our distance from this planet. So we'll go ahead and get planet. And we will do get actor location. We'll go ahead and just subtract a vector, and we'll get actor location. Boom. And this is going to be the point in space that this planet's at, and the point in space that we're at, subtracted from each other, and we'll get the vector length. And this is going to tell us how far we are from the origin of that. But that's not what we care about. We don't care about the origin. What we care about is the distance to the surface. So how do we find that? Well, assuming you're working with spheres, if you're working with ellipses or any other shape, one, the gravity is going to be really weird, and two, this won't work. It won't be the same, but let's assume we're working with spheres. So what you can do is hop in and click on whatever your static mesh is to bring it up in the content browser. And if you look, it says approximate size 100 by 100 by 100. So that's the dimensions, and what we want is half of one of those, which will give us the radius, because that's 100 from top to bottom. And what we want to know is what's the distance between the origin here to the surface. So in this case, it would be 50. So I'm going to jump back to tutorial and back into here. And so what we want to do is multiply 50, which is the radius of our mesh, times get actor scale 3D. This again won't work if you have okay, so we're going to break this, and this is again assuming that you scale this all the same. If you're making it a weird shape, you're scaling the x and not the other two, this won't work, but just grab the x and stick it in there. So this is multiplying this the radius if it was at scale 1 times its current world scale 3D, assuming that you've scaled the entire actor and not the mesh inside the blueprint, the planet blueprint. So what we're going to do then is take this length, so the distance between the planet and yourself, and subtract minus this distance here, which is the radius, including the scale, and that will give you your distance to the surface, approximately. All right, and what we need to do now is for each, and the array that we care about is this. So for each of these, what we want to do is replicate this, except for instead of using planet in these two pins here, we want to use this planet. So it might be the same, and that's fine, but it could be one of the other ones. And what we care about is that this now is the distance between us and whatever element you're looping through, and this is the distance between us and the current planet. What we care about is if this is less than this, so they're swizzled right now, I know, but what we want to know is if the new element that we're looking at, the distance is less than the distance between you and the current planet, then we want to set the planet to this 1. Sorry. If it's not, we don't want to do anything. We want to leave the planet that we've got set. Compile, save, and we'll go to the event graph. And at the end here, we're going to drag out set planet and run that right into there. So now, if I've done everything correctly, when you come in, you're now gravitated to this one, which you notice is the second planet we put in. And then when I get closer to this one, it does that. However, and this works perfectly well, but boy, it's jarring moving between the two of them. If all you care about is being able to get between the two, and you don't care about smoothing that out, you can just go ahead and stop watching now. That's all there is to it as far as setting the new planet. This will work for any arbitrary number of planets. Let's copy this out, and we'll copy it out again, just to pull it off axis here. So I'll go to that one first, and then I can jump. I'm hitting jump multiple times because we never limited the number of jumps you have. So you have double, triple, quadruple jump. So jump over to this one. And actually we'll go to this one. And it works for any number of planets. But it is jarring. So the next thing I'm going to do is a little bit hacky. Or you can call it clever. I prefer clever, but in reality it's just hacky. But it solves the problem and it runs really smoothly. So I'm going to show you how to do it, and people can complain in the comments if they don't like it. So the problem is that we're setting the rotation every tick just to whatever the nearest planet is. And because we're running this on tick, it's happening immediately as soon as we switch. So I thought, boy, it would be nice if we could do this in a fraction. So one way to do this would be to set up a timer and Boolean this like transitioning, and when you switch here, when it in set planet, it sets transitioning to true, and then when the timer finishes, it sets it to false. And we don't do all this, and all of the rotation is driven by the timer. And that works fairly well. I actually set it up like that once, and it works fine. But sometimes you end up with weirdness around, like if you transition in and then transition out, then it keeps rotating you towards the planet, even though you should be rotating towards the other, and it doesn't get set to transitional state correctly going back the other way. So there's definitely some room for weirdness to come out of that. So instead, I thought, well, maybe what we can do is use the ease node in a kind of a non-standard way. So what I did was I get actor rotation. I want to ease between my current rotation and this rotation, and I want to use the shortest path, and linear is fine. And we want to end up here, and right now this isn't getting an alpha, and you might think, well, how could it possibly get an alpha? And this is the non-standard way that I decided to use it. I thought to myself, well, what if you're really close to the planet, this alpha is 1 or greater, which, you know, because it's an ease function, will clamp basically to 1 or overdrive it to 1, and it'll just put you at the full new rotation. But if you're farther away, this alpha is set to a lower number, so that you actually only rotated, in any given tick, you're only rotated a fraction of the way between here and there. So the solution I came up with for that, and there's probably a better solution based just sheerly on the distance away from the surface that you are, but the solution that I came up with is using a timeline. We'll call this rotation easing timeline. And of course, we need to set it to active, so let's go ahead and get it here. Set active, and this is on event begin play. We'll set it to active. Oops. New active is true. And the more I think about this, the more this really should just be done by the distance away. In fact, I can probably, let me take a look at the template pawn here. Template pawn. At this, I bet I can just take this and not use the timeline at all. You know what? Let's well, no, I'm gonna need to use the timeline, and then I can correct this later. No, you know, we're gonna use this. I'm gonna wing it here for a second. I'm going off script. So basically the idea is, hey, when we're far away from the planet, we want the fraction to be kind of low. And when we're close to the planet, we want that fraction to, whoa, don't know why I clicked that. We want the fraction to be 1, fully 1, or overdrive that so it just, you're gonna be upright. Tutorial pawn. So this is gonna be actually reversed here. Let's take this out, take this out, take this out. This is gonna be reversed, all this code here. Whew, doesn't like that. Get planet. Yeah, that's fine. So what this is doing is it's getting planet mesh. Get mesh. What is it called? What did I call it in this? Get root component? Is that? Whatever. So what this is doing is actually something kind of similar, so ignore that for a second. What this was doing was setting the length of the timeline, and it's doing something kind of similar to what we were doing to get the distance. But we're probably going to have to reverse this so that it gets bigger the further out, not vice versa. It's getting the distance, it's figuring out what the distance to the surface is, even though I had a different mesh, so it needs to be 50 in this case. And then it was dividing it by 3,000. And what that was doing was making the timeline really short. And then this alpha was basically getting the current time. So if the timeline would be so short that after however many fractions of a second it took between frames, the timeline would have quote unquote already completed. So the time would be already past. Well, I was taking the total length divided by where it was at, or where it was at divided by the total length. So that value would come out to 1 if that time was sufficiently short, because literally one frame would take longer than the length of the timeline, and you'd get 1 pumped into alpha, flips you upright. But if you're further away, then the timeline would only be, part way through. Let's say like it's, I don't know, however many milliseconds, and the delta tick was a third of that. Then it would be a third of the way through, so you'd only get a third of the rotation. And the further away you were, the more pronounced that effect would be. So we're going to do something similar. What we want, though, is we do want this to be clamped between, say, 0.0 and max 1, but I don't think we want to be dividing by 3,000. So what do we want to be doing? So this is the distance between us and the surface of the planet, and as we get closer, we want this to be higher. So what we want to do is we might want to do, maybe it's divide, float by float. We'll actually divide by this number. Now we don't ever want it to be 0. So what we'll do, say 3,000. Oh, that's why we're clamping here. Okay. So let's see if, so I'm going to print this out. String this value out. And I'm also going to drive it into the alpha. So it's probably going to act weird because I probably didn't do this correctly, but we'll see what the values are as it's, and this is current planet. Yep, okay. All right, let's see what we get. So it's 1 no matter what right now, which means that we're just going to have a really sharp rotation. So we need to 3,000 divided by the distance. Let's do, the distance isn't dividing it enough, so let's do 100. This might work pretty close to correctly. Yeah, that's doing it. It's still a little bit more jarring than I would like, so what we can do is actually shrink that 100 down even more. So let's take this down to 10. Because really we only want it to be like snappily rotated to the surface, right when you're on the surface. When you're like going in between, you want it to have that smooth transition. So there you go. So yeah, this is less hacky than what I had, and I feel good. I feel good about this. It's still on event tick, which isn't great, but we have a smooth transition. So let's clean this up a little bit really quickly here, and go over what I did again, because I know that was off script. That's kind of abnormal for me. I usually just do exactly what I did before. So set planet, set physics linear velocity. This is the gravity. Right. So we'll go ahead and stick this in set planet, set gravity. Pull this back, and this is just, this whole mess is going to be inside one comment. Actually, we don't even need that one. This whole mess is going to be inside one comment, that is set rotation. But I can, so first of all, I can get rid of the stupid print string, run that in there, and this whole thing can be put into another comment that is basically how to, about how to calculate all of this. Oh, and this is the forward vector still. So this is, some of this is actually not part of the same thing. So what we might want to do here, promote this to a variable. We'll call this down direction. We're going to set down direction, and then what we'll do is we'll get down direction for the gravity instead of, well, I guess it'd be up direction. I'll rename it down direction because we're inverting it here for our gravity. So let's rename this up direction. All right, so now what we're doing is calculating the up direction, and we can pull, I don't need that, this stuff all up and away from this mess. So this down here is where we calculate ease amount. Okay, so what we're doing here overall is we're finding the, you go in here, you guys go in here, and you go in here. Okay. Isn't it beautifully organized? Isn't it great? This is actually way better than a lot of my projects look. So, and then this is all calculate up. Okay, this is actually pretty well organized. I mean, I know the lines are kind of still going everywhere. It's not beautiful, but it's actually fairly well organized. This can go into here. Right. Ease. All right, so again, what we're doing, we're calculating an up direction, and we are basically rotating towards that up direction, but we're not rotating all the way to it unless the alpha is 1, because we're using this nice ease function. Pardon me. So we're rotating to the up direction based on an alpha. So if the alpha is 0.1, we'll rotate 1/10 of the way there. If it's 0.01, we'll rotate 100th of the way there, and so on and so forth. Of course, 0.01 is the minimum amount we allow here. It's important that you clamp above your frame rate. So if your frame rate is 120 frames a second and you're allowing this to be below 120th of of 1/120th of 1, then you won't actually rotate at all. So I've seen that happen. So I put it at 0.1 because my frame rate is pretty high. But if your frame rate is going to be low, you're going to want to put this on like 0.3 or something. Sorry, not 0.3, 0.03, or 0.05 or something like that to allow for it. And it'll still work pretty well. It's just going to rotate you a little bit more quickly. I think 0.02 or 0.01 is fine. But once we calculate the alpha based on the distance, so the closer you are, the higher the alpha is going to be, then we ease the rotation amount, and then we just set that rotation solidly right there. We do our gravity as usual, and then we have our setting planet, which again gets the distance between you and the planet, and you and whatever the next iterator in this loop over all the planets are. And if you're closer to this, then it sets as the new planet. And that's it. I hope you guys found that helpful. That was a little bit longer than I intended. I was supposed to do this for about 15 minutes, but I think there's some valuable stuff in there. Let me know if you liked it. Like and subscribe if you think this deserved your like and subscribe. And let me know what else you want me to do. I'm going to do a few more in this series, maybe some moving planets and talk about some issues there. But thanks for watching, guys.